So what we're going to do for solving these equations is use an idea of trying to get the bases the same. And so our powers chart that we wrote, what we're going to do is we're going to look in a question like in A we have 4 to the x equals 1 over 256. Do those numbers happen in the same column of our powers chart? So if we go back to our powers chart that we wrote down, wow. Or attempt to go back. So here on our powers chart, do 256 and 4 ever appear on the same column? Well, they do in two different places. You can see in the column of 4, we have 4 and 256. So that'll probably be the easiest one to use. But we also see that we have 4 and 256 in the column of 2. So what does that mean for our question? Well, we can write 256 as a power of 4. So I have 4 to the x here, and 256 was 4 to the power of 4. Now we're close here. The goal is to get the bases the same. Here I have 4 to the x. Here I have 1 over 4 to the 4. I would like both sides to be 4 to the something, and so this is where we're going to use our exponent rules and say, what's another way that I can write 1 over 4 to the 4? Negative exponent rules, 4 to the negative 4. And once both sides have the same base, then just by observation, what's x going to be? X has to be negative 4. So if we can get our bases to be the same, then the exponents would have to be the same, and we can solve them. In this case, we could solve it directly. When we get to part B here, 27 to the x equals 9 to the 2x minus 1. Now, if we go to the smaller of the two numbers, which is the 9, and look in our powers chart of 9, 27 does not appear. So now we have to look at other powers and say, is there any other place that 9 and 27 are in the same column? Yes, they're both powers of 3. So what we can do is we can change 27 to 3 to the 3, and we can change 9 to 3 squared. And we're close, but we don't have both sides as just a power of 3 yet. We need to use our exponent rules. What is the rule for an exponent to an exponent? Do you add them, multiply them, divide them, or guess? Exponent to an exponent, you multiply. Again, if you're ever wondering about it, go back to simple numbers. What would happen if you had 2 squared cubed? Well, what does this mean? 2 squared means 2 times 2. Cubed means whatever you have 3 times. So how many 2's do we have all multiplied together? 6 of them. So how do I get 6 from 2 and 3? You multiply. So that can sometimes help you realize, oh, in this situation, I'm going to need to multiply as well. And when I multiply 2 times 2x minus 1, I'm going to have to distribute. And so now I have both sides with the same base. What does that mean? If these two things are equal, it means that 3x has to equal 4x minus 2. Sometimes I even like to write, while I'm doing my math, I haven't done something algebraic. I've done something more by observation at this point. So I write like, so 3x has to equal 4x minus 2. And if I rearrange here and solve things, I'm going to put the 2 over to this side, move the 3x, and there we go. We can solve for x. So if we can write, if we can get the bases the same, if we can get the bases the same by using our powers chart and then using our exponent laws. So in the first one we had to use a negative exponent law to get the bases the same. In the second one we had to use our exponent law of a power to a power's multiply to get the bases the same. And if we can do that, then we can equate our exponents, because they would have to be equal, and our equation becomes something easy that we can solve. In the first one, it solved right away. In the second one, we still had to do some rearrangements to figure it out. Okay, questions for practice 3, 4, 5, and 6, and we will do some of those right now.